Hello, everyone. So, today I'll be trying to cover two medium level questions using Kadane's algorithm. Okay, people have stopped their mind with only this four templates, not even just four. They have think that okay, Kadane's algorithm is just to find maximum sum subarray. There couldn't be any deviations in it. There couldn't be any variations in it. But there are so many problems which I had seen that can be solved easily with the Kadane's algorithm. But you need to have a catch on that. Okay, so this is one such question. This is the lead code question, of course. Uh, it's given that you are given a circular integer array now. So until now, you are given single integer array. Now this is circular. This means the last element of this array and first element of this array is connected, and you need to return the maximum possible sum of a non-empty subarray of nums. So now what you need to do, you need to return the maximum possible sum of, and it is mentioned clearly, of non-empty subarray. Okay, so we have to do maximum possible sum and non-empty subarray. So our second template, as we have learned from yesterday's video, I would strongly suggest you to go and watch out the first video of Kiran's algorithm, okay, before starting with this, because that will be very useful if you have watched that. Okay, so the question is nothing but simply we need to find the maximum possible sum in the non-empty subarray, but this is the circular integer array. This is not the simple straightforward array, it's the circular integer array. So what we can do, the similar type of question which we have done in sliding window also, wherein circular is given. And I had told you one hack over there, that whenever a circular is given, what we can do. So that's the same question where we need to find something like maximum possible ones in between, and there are ones and zeros. So maximum possible ones possible in the circular array. So what we had done, the answer could lie either in the middle somewhere, or somewhere starting from the middle and ending at the front. So like 3 minus 2 1, somewhere you need to start from middle and then go until end, and then you need to consider the elements at the front. So that could be two possible answers. Okay, there could be two possible answers. Remember this, whenever circular type of questions come, this could be one of the solution which you can, this could be one of the direction in which you can think of. Okay, so there could be two possible answers. Either the answer lies in, either the answer lies in middle of the array, in middle of array, or or connecting end and start element. When you connect this to end and start element, then your answer could lie. So there could be two possible case. One is either your answer lies in the middle of the array, or one is if you connect from the end and go until the start point of the array. This could be the two possible scenarios. Okay, so now what you can do, for answer lying in the middle of the array, it's the simple, for the straightforward array. So we can do maximum sum sub array. Okay, for non-empty, for non-empty sub arrays, that is using second template we can do this. Okay, using second template we can do this. But what for the array connecting, or our answer is lying between, when we need to connect the end element and the start element, what we can do. So other possible could be, we could find minimum sum subarray in between only. Okay, minimum sum subarray in between only. That is the fourth template. And we subtract that from our total sum. Okay, so if we could find minimum sum subarray, so if I could find this, okay, let's say this is the minimum sum subarray, and I could subtract this minimum subarray from the total, then all the elements uh, on the front and the back of it will be connected, and it could make the maximum possible sum if I remove this minimum sum subarray. So let's say this is the first case where you are given 1 minus 2 3 minus 2. So your maximum possible sum could be what? Only 3. So maximum possible sum could be what? Maximum possible could be 3. And what could be the minimum possible? Minimum possible sum could be minus 2 plus 3 plus minus 2 will be minus 2 plus 3 plus 1 minus 2 minus 1. So we could take only minus 2, only minus 2. So there could be like, okay, this is the original answer, it could be possible. Or another possible scenario, I will remove this minus 2 and I will connect this all things. So 3 minus 2 plus 1 plus 1. So 2. Total minus this will be total minus minus 2, which is giving me So that could be one of the answer. So maximum of this both, maximum of 3 and 2 will be your answer for sure. Okay. Now let's say this is the case. Here your maximum possible sum will be 5. Of course, you will take either this 5 or this 5. But if you will take everything, it will be 10 minus 3, which is okay. You could take everything also. Okay. So your maximum possible sum could be 10 minus 3, which is 7. Okay. This is your maximum possible sum when you will take everything 10 minus 3, which is 7. Okay, what will be your minimum sum sub array? So your minimum sum sub array, of course, minus 3. Only this much, minus 3. So if you will subtract this from your total, so total is nothing but, we have seen total is only the maximum possible answer, 7. And if we'll subtract this minus 3 from here, we will get 10. So if we will remove this minimum possible sub array, then 5 plus 5, this 2 has become, and the sum has become up to 10. Here the use of circular array came. So here the use of total minus minimum sum sub array, and one could be maximum sum sub array. Clear? I'll be giving you the question link in the description and you can solve it by yourself now. You know the second template, you know the fourth template, and I have given you the idea also. I hope you got clear with this, with the circular integer array. So I'll be giving you the question in the description. You can solve that. Let's move to our another question now. Okay, so we are given an array consisting of zeros and ones. Now, a flip operation is one in which you turn 1 into 0 and 0 into 1. So, they are explaining what is flip operation. Okay, we'll make 1 to 0 and 0 to 1. You have to do at most maximum one flip operation of any subarray. We can do at max one flip operation of any subarray. That means either 0 or either 1. But this flip operation is not for single digit, it is for one subarray. We can apply it to any one subarray. Now we can choose what subarray we have to take into consideration. So formally, select range L to R in the array A such that L to R is between this holds and flip the element in this range to get the maximum ones in the final array. So we need to flip the elements of those subarray which we have chosen. Let's say from L to R as given here, and we have to flip those bits, and after flipping, now we need to calculate what is our maximum number of ones. You can possibly make zero operations, as of course it's given at most one only we have to do, so either 0 or 1, so we can do zero operations also to get the answer. You are asked to return the maximum number of ones you can get in the array after doing flip operation. Okay, so let me give you the example now. Let's say you are given as an array like 1 1 0 0 1 0 1. Cool. You are given this array. You can choose any one subarray. So logically seeing, I can choose this subarray. Okay, and I can convert this two zeros to two ones, and then this full will be ones. So my total number of ones will be this four ones. Of course, it's there, and I have converted this two also to one. So 4 plus 2 will be 6. So I had in total 6 ones after converting this subarray which I'm highlighting from zeros to ones. So I hope you got the question. What? Now, how we will use Kadane's algorithm? Okay, let me make you sure that if the question said that you can flip any one element or two element or at most one element or at most two element, then we have done the similar type of question in sliding window. You can go and watch out there. Okay, in either at least at most or in variable size sliding window, any one of there, I have, whether I've given in the description or I've solved it in the video itself, you can go and watch out. So if it's fixed that how many maximum we can do, then it's good. But here it's not said any number of values which you can change. It said that you can flip any one sub array. Now sub array could be of any length, it could be full array, it could be empty array also. Okay, so this means that it could be an empty array also. Empty array means zero operations, no sub array we have to choose. So this means we have to consider empty sub array. Okay, now we have those templates under us. Now what we will do? Now what I can do, let's say um, what we can do is, let's say I'm not converting zeros, I'm making zeros as zeros and ones as ones. what I can do is I could find the total number of ones, how many present, okay, initially. And now I need to do how many zeros I can convert it to 1. Okay. Now I can make minimum sum subarray. So after making minimum sum, I could get that what is the minimum possible sum I am getting. But with the zeros, if I add 0 with 0, it will be 0 only. So you every time your minimum sum subarray would remain 0 only. So you won't recognize how many zeros in one subarray you have taken which have summed up to 0, and that much zeros you need to convert to 1. So this way we cannot get. So what we can do is we can convert zeros to minus ones. So my logic says that let's say we have converted zeros to minus ones. Okay. Now I could get the minimum sum subarray. Now I could get the minimum sum subarray. So what could be my minimum sum subarray for this? Minus 2. Of course, minimum sum subarray could be minus 2. So total, how many ones I have got? 4. And I can add this. So not with the minus signs. Okay, minus sign we have changed it. So that means there are two zeros. That's where my sum has came. Minus 2, of course, there could be two zeros. So I would change the absolute. I would add the absolute of this value, which is 2 over here. So my total answer will be 6. Now there can be question arising like, okay, let's say I have this type of question where I have this thing. Okay, so anyways, I have initial ones like 1 only, and now I'm converting this. So minus 1 minus 1 1 minus 1 minus 1. So what could be my minimum possible sum? What could be my minimum possible sum? Minus 2, minus 2 plus 1, minus 1, again minus 1, minus 2, minus 3. So minimum sum subarray could be minus 3. By taking full subarray, by taking the full array, I could get the minimum possible sum to be minus 3. Yeah, that's true. So what does this mean? Does this means that only 3 zeros are converted to ones? Does that means like that? Let's see. Okay, so anyways, I will be flipping all the zeros, right? I can take this. I can take this. So this means minus 3 has came. Why? Because I have considered full subarray. So I'm flipping full subarray. This means that the zeros, this two zeros will become ones. This one will become zeros and this two will become ones again. So anyways, this 1 and minus 1 is combining and making it 0 only. Okay. So this means only, I could say that only 3 zeros extra I had made it to 1. Other than that, this 1 1 I have converted it to 0, and 1 0 I have converted it to 1. So anyways, my answer is satisfying over here also, which is 1 plus minus 3 in absolute form, which is nothing but 4. This is the absolute. Okay. So 4 ones I could get. This is the 4 ones. These are the 4 ones. Actually, these are the 4 ones. But for our calculation part, I hope you got my point. I am making 1 1 to 0, and in the similar way, I'm taking that full subarray. So of course my 1 will also be flipped to 0. They haven't said that only zeros will be turned to 1. Ones will also be turned to 0. So that way your answer is satisfying. And now why empty subarray? So let me take the third test case where there are all ones. Okay, so if you will not take empty subarray, if you will take non-empty subarray, at least one you need to take. So your answer would be minimum 1 in that case. In that case. So your total ones are, let's say, 5, and you would add the absolute of this, which is 1. So you will get in this case 6, which is wrong. Anyways, you cannot make 6 out of the 5 ones, or the total size of the array only. So here it comes the picture of empty subarray. So when there are no minus elements in this, we could take the empty subarray and our minimum sum could become 0 in that case. So answer will be nothing but 5 plus 0, which is 5 only. Full subarray. I hope you got it. Let's just quickly code it and you can see that. Okay. So we will have one count, which will be counting our ones. So what we will do, if our a of I value is 1, we will count it. Otherwise, we will make, otherwise it will be 0. So we'll make it to minus 1 to find the minimum sum subarray. So now our minimum sum for empty subarrays, we would initialize it to 0. And our sum also to 0. We'll run this loop. Sum plus equal to a of I. First, we will check in the empty part. So if sum has become greater than 0, we will do it again to 0. And now we will do minimum of minimum sum, comma, our sum. And now we will return this count plus absolute of whatever minimum sum we have got. So that much difference of zeros we have converted to ones. I hope you got this point. So this is how we'll use Kadane's algorithm to solve. This is the modified algorithm. Okay, we need to use and tweak the Kadane's algorithm and involve it to calculate the answer for this type of questions. Okay, in the next video, I'll be coming to a little bit harder level than this of the Kadane's algorithm. So stay tuned for the next video. If you have learned a lot from this 4 templates, do like, share, and subscribe, and share it with your friends so that they can also learn. Okay, stay tuned for the next video. Bye bye.